There are so many edible things around us. Let us classify these things based on how they taste. Some of them are sour to taste and some are bitter to taste. Tamarind. Tamarind is sour to taste. What about gherkin? Gherkin is bitter to taste. Then lemon. It is sour to taste. Then we have spinach. It is bitter to taste. What about vinegar? Vinegar is sour to taste. And bitter gourd? It is bitter to taste. Okay, all the things which are sour to taste have some acids in them, and things which are bitter to taste have some bases in them. When I talk about tamarind, tamarind has an acid in it called tartaric acid. Lemon has citric acid, whereas vinegar has acetic acid. Now, do you know one fact that your body has acid present in it? Acid is present in our stomach. This acid helps in digestion. So when sometimes the food is very delicious and you overeat, that time the acid produced in your stomach is more. This acid is called hydrochloric acid. Now, if the acid increases in your stomach, this leads to acidity. What will you choose to curb the acidity? Will you choose lemon juice or vinegar or baking soda solution? Well, in this case, you should choose the baking soda solution because baking soda solution is a base. Now, acids and bases are opposite in nature. So, to cut off the effect of acid, we can apply a base, and to cut off the effect of a base, we can apply an acid. They neutralize each other when they come in contact with each other. Okay, so now we know that acids are sour to taste and bases are bitter to taste. But what is the chemical definition of acids and bases? A definition that you will be writing in the subject of chemistry. Let us define acids. Before that, let us consider one very common example of acid that we use in laboratories. That is hydrochloric acid, HCl, which is also present in our stomach. Now, HCl has hydrogen and chlorine in it. Both are nonmetals, and nonmetals combine with each other by sharing of their electrons. So, right now in HCl there is sharing of electrons. Now, as soon as hydrochloric acid goes in water, both hydrogen and chlorine split, and when they split, hydrogen gives away its shared electron to chlorine and chlorine accepts that electron. Okay, now due to this, H becomes plus and Cl becomes minus. Hydrogen gains a positive charge and chlorine gains a negative charge because of the extra electron. So, our equation looks like HCl gives H plus and Cl minus when it goes in water. Now, let's take one more example. Sulfuric acid. The formula of sulfuric acid is H2SO4. Now, here hydrogen and sulfate have combined together by sharing of electrons. Again, they are nonmetals. So, once they go in water, again they will split. So, hydrogen will give away one electron and sulfate will accept that electron. But sulfate's valency is 2. So, sulfate has a tendency of accepting 2 electrons, due to which we require 2 hydrogens to give sulfate their electrons. And that is why the formula is H2SO4. So, when it splits, it gives H plus and SO4 2 minus, and when we balance the equation, it becomes H2SO4 gives 2H plus SO4 2 minus. Now, this is called dissociation. Now, check both the equations. You will find that in both the acid, one ion is common, and that is hydrogen ion. So, remember that acids always give hydrogen ion in water. So, we can define acids as substances which give H plus ions when dissolved in water are called acids. Let's come to bases now. Common example of base is sodium hydroxide. Now, in sodium hydroxide, we have sodium, which is a metal, and hydroxide, which is a non-metallic part. So, that is obvious that metal gives electrons and non-metallic part takes electrons. So, now NaOH splits and gives Na plus and OH minus. Na gives 1 electron and OH accepts that 1 electron to form NaOH. Similarly, if I take KOH, that is potassium hydroxide. Now in potassium hydroxide, potassium is a metal. So when potassium hydroxide goes in water and splits, it gives K plus and OH minus. Potassium gives 1 electron and again OH accepts that 1 electron. So now when I talk about bases, you can see that OH minus ion is common in both the base. So bases give hydroxyl ions when dissolved in water. OH minus are called hydroxyl ions. So we define bases as substances which give hydroxyl ions in water are called bases. Okay, let's take one example and let's see if you can write the dissociation of this example. We have calcium hydroxide. Calcium hydroxide's formula is CaOH twice because calcium's valency is 2 and hydroxide's valency is 1. So now when calcium hydroxide dissociates in water, what will it give? Well, calcium's valency is 2, so it will give 2 electrons. So calcium becomes Ca2+. But hydroxide's valency is only 1, so it will accept only 1 electron, so it will become OH minus. But because calcium gives 2 electrons, we require 2 hydroxides. So to balance the equation, we write 2 ahead OH. So the equation becomes CaOH twice gives Ca2 plus 2OH minus. Okay, now when we talk about bases, not all bases dissolve in water. And the bases which dissolve in water are called alkalis. So remember one line. All the alkalis are bases, but all the bases are not alkalis. Only the bases which dissolve in water are called alkalis. For example, sodium hydroxide and potassium hydroxide are called alkalis.